Okay, so we've done a lot of the basics right now. We're gonna move on a little bit and talk about operators, how to do operations with specifically with numbers. We're gonna talk about the arithmetic operators such as plus, minus, multiply, divide, remainder, and so forth here. Again, push everything down so we have a clean slate per se. Okay, I'm gonna say int number 34, say int number 2 as such. So we have two numbers, variables of type integer, one 34, the other one is 2. So what do we do to add those two numbers? Well, to add those two numbers, we can go ahead and say print, and I can say number, right, plus number 2. That's it. Save this and run. And look at it. It says 36 because 34 plus 2 is indeed 36. Now, if I wanted to add this 2 and put in a variable, I could have done the same. Obviously, I could say var result is equal to number 2 plus number 1, or number in this case. And then I just go ahead and pass result to print. Okay, and run this, we're going to have the same result. Okay, this is another way here. All right, same thing I could do with doubles. I can say double, let's say pi 3.14, say double, let's see, what is another constant? Gravity, I'm going to say 9.8. This is obviously the metric system. All right, and I want to multiply those two. Of course, I can go ahead and just say, and I want to add those two. I can say pi plus gravity. Give it a run. You should see we have 12.94. Okay, and then 0.000.1. So there we go. We can actually add numbers by using the plus sign. Very easy. Nothing new, nothing from the other world. How about subtracting? What do you think we could do? Very nice. You can just go ahead and say minus, and in this case, just say result. If you run this, we should have minus 32. Why? Because number 2 is 2, right? So 2 minus 34, it is indeed minus 32. We can do here pi, and say gravity minus pi, and that's going to be 6.66, right? Because 9.8 minus 314, it is indeed 6.66. Okay, those are very simple ones that we can use, obviously. So we know how to do minus and plus. That's very simple. So for multiplication, we use the asterisk. Okay, so if you want to multiply those two numbers, just put the asterisk in between there, and I can say result. Give a quick run, it's 68. So number 2 times number is indeed 68. 34 times 2 is 68. So these are all arithmetic operators. Okay, so we have multiply, plus, addition, and subtraction. How about dividing two numbers? So let's go ahead and let's say we want to divide 34 by 2. In this case, it's actually going to be 2 divided by 34. Let's see what that's going to do. Save this and give. It's going to give us 0.058, blah, 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 blah. So what's happening here now, we are getting an actual decimal number. This is a huge difference here. So if you're coming from Java, notice this would have been very problematic because it would probably show up as just 0, right? But Dart is very smart. The Dart language is very smart in the sense that it knows exactly that because these two are integers, and 2 divided by 34, so a small number divided by a big number, the result's going to yield to a double. So this is one of the things that we don't have to worry about in Dart. So if you're coming from Java specifically. Okay, that's pretty cool. So we don't have to do any translation or any parsing or any casting or any of that. It just knows exactly what to display as a result. Okay, so if we have whole numbers, so 4 and say 2, you're going to see it's 2.0. Okay, 4 divided by 2 is indeed 2. Let's talk about the remainder. In this case is the percentage sign here. So what remainder is, if you're not familiar with, so a remainder, I like to think of it as what remains from a division operation. So a good example would be if I say 4 divided by 2 and I ask remainder, what is the remainder? Well, the remainder is 0. The reason why is because, so if we divide, say 4 divided by 2, it's a whole number, the result, which is 2, because 2 times 2 is 4, so there's no remainder. But if I say 4 divided by 3, now the remainder is going to be what? 1. Why? Because 4 divided by 3 is 1, because 1 times 3 is 3, but to get to 4, we need 1, right? So the remainder is indeed 1. So that's the idea here. Now, this concept here, it really is helpful when we start getting to advanced calculation of certain things. Let's say we're building an application where we're receiving a stream of numbers. Okay, 1, 10, 15, 40, 60, 1,000, 1 million, just different random numbers, right? And we're going to say, okay, we're going to loop through all this stream of numbers that we're getting. And so as we loop through these numbers, each time we get a multiple of 2 or multiple of 3, we want to do something, right? So that's where a remainder really comes to place. So if, for instance, as we are looping through this stream of numbers and we get a 4, well, 4 is indeed a multiple of 2, which means then we, in our for loop, we can add an if statement that says if we get a multiple of 2, we are going to do something. Maybe take that number and multiply it by 10 or whatever else that we need to do. There's a lot of ways we can use the remainder operator. Okay? So let's do a quick example here. To give an example, again, using 4, if I go ahead and say 4, and I say remainder or percentage sign 2, let's see what's going to print. 0, like I just said here. I gave that example, okay? Why? Because 2 times 2 is 4, and there's no remainder. Again, if I go ahead and put 3 here, we should get a 1. And there we go, remainder is 1. Why? Again, 4 divided by 3 is 1, but 1 times 3 is not 4, which means we have to add another 1. There's a remainder of 1 for us to yield back to 4. In subtraction, addition, multiplication, division, and remainder. Perfect. Very cool. I'll see you in the next video.